Hi everyone. This is uh, week 2 statics for statics 1 IIT Madras Bachelor in Science, Data Science and Programming. So in week 2 syllabus, first we will be uh, talking about categorical data in single variable. So in previous lecture we discussed that there are two types of variable. First is categorical, and second type is, it can be also said, qualitative. And second type of variable is numerical, or we can say quantitative. So these are two types of categorical variable, and first we will be talking about this one. So to know about this type of variable, we will be first notice its characteristics. From that I mean, I'll be first introducing frequency distribution, which is pretty important to understand a variable. So in frequency distribution, this so this frequency distribution of a qualitative data is listing of distinct values and their frequency. So these values can be a variable count. So suppose we have a variable. Let me just start off with an example. So let us suppose we are taking for a category variable, education levels. So value here variable is tenth passed, 12th passed. It can be diploma, bachelor's, master's, or PhD, postgraduate. So here let us just make a table. It's a basic criteria to solve a frequency distribution. So here, first of all, in a variable 10th, 12th, diploma, it's the highest level of the education. Let us just denote bachelor's with B, master's with M, and PhD with P. So here we took a survey of 40 people. So total individuals were 40. So here one thing you can notice is that variables here do not have some numerical quantity. We can say that it does have the order. So in this case we will say this is a categorical variable and on an ordinal scale. 10th is here lowest level of education. So following the ascending order, after 10th we get 12th. Some may opt for diploma, some may opt for bachelor's, but we all know bachelor's has higher respect in regarding of level of education. Next is masters, and at last is PhD, which is postgraduate. So survey was conducted on 40 people. 3 of them had 10th as their highest education, 12th passed were 8, diploma passed were 4, who completed bachelors were 12, who completed masters were 9, and PhD level students were 4. So this was the total analysis we got. So what we will say is this is variable value. Let us denote it with VV, and here let me erase this, I'll write it somewhere else. So total is 40, let us just write max is 40. So this is a frequency. Okay, so now we obtained a frequency. We already know which scale or which interval our data consists of. Now we will find relative frequency. To find relative frequency, what we do is to first sum up all these values, which would be 3 plus 8 plus 4 plus 12 plus 9 plus 4. Let me calculate. 12 plus 8, 20, 24 for 8, 28 plus 11, 40 exactly. So 40. And now what we will do, we will divide 3, like how many on a relative scale of total people were 10th passed. So number of people from 10th passed level of education divided by total number. So it would be approximately 0.075, I suppose. Yeah. So in 8th it would be 0.2, 4 would be half of that, so it would be 0.1. Similarly, this would be 0.3, this would be 0.225, and for postgraduate it would be again 0.1. So this is a total relative frequency. Again, we can make more and more further calculations on this topic. Like we can even calculate percentage, which would be here 7.5%. We will just multiply it by 100. Okay, so 7.5%. So by multiplying with 100 means that if there would be 100 number of students in a long run, we can say 7.5 number of individuals would consist of 10th standard. It's just an approximation, so you don't need to consider that. So 20%. I hope you are understanding my point. 30%, 22.5%, and 10%. So this is all about frequency distribution. If you have any queries, you may contact me through comments. So next, let me give you another example. So suppose there's a married, single, and divorced. These are the variables here. So again, this is a categorical variable. Here survey was conducted on total of 100 number of population. So our sample space was 100. So here merit count was found to be 34, single count was found to be 58, and divorced was found to be 8. Again, you can calculate this. It's simple. By 100, so 0.34, 0.58 and 0.08. For percentage, we will just multiply it by 100. So percent RF, relative frequency, and frequency. So actually, the thing is, in our syllabus, at first we will deal with unstructured data, where our data set would be something like for an grades of student of 20 students, we will be given that grades are A, C, B, D. There are 4 grades, A, B, C, D. Okay. So D, A, C, B, A, D, B, C, and something like this. This will continue up to 20 total number of different values. So this will be our data set. So to count these, there's a basic, or you can say efficient way of calculating. That would be telemark method, you can say, or you can say just calculating frequency by telemarks. So first of all, what you will do is to define your variables A, B, C, D. Now telemark these: 1A, again 1A, 1C, 1B, 1D, again D, A, C, 2 times B, A, 2 times D, B, and something like this. This will continue, and for 5 you will denote it like this: 4 and 1 slash, this would mean 5, and this will continue, and you can efficiently find total number of frequency. So those who don't know how to calculate telemark, let me just write it down numerically. 1 will be like this, 2 will be denoted 2 lines, 3 will be denoted like 3 lines. Similarly for 4. Now here's a twist: 5 will be denoted like this. Again for 6, you can say it's a bundle of 5 plus 1 line. For 7, it would be bundle of 5 with 2 lines. Again 8 would be 1 bundle with 3 lines. So this will continue. For 10 it would be 2 bundle. For 15 it would be 3 bundles. So let me just give you another example. For 23 it would be 4 5 bundles. And 3 simple lines. So you can just observe what's going on. So in the end, those who didn't understand, let me just give you a simple example related to a current situation. Suppose we need to find which variant of coronavirus got how much frequency of infected people. So corona pandemic, it's pretty interesting example because it's a real life situation. So first of all would be number of infected people. So we will divide the table whole by 2. So number of infected, and we will not write it like this, just simply infected, non-infected. Okay, so here we can again divide these with recovered, death, and still infected. So we got total of 4 different variables: 1, 2, 3, 4. Or in non-infected, you can even divide it like there are many possibilities. So I'll just end this whole here. So we can just say there are 4 types of different categorical variables, and we need to find these to have a better statistical analysis in your area. What you need to do is just type corona update on your Google or whatever your browser is. You will find a statistical analysis. You can change those by weekly. You can filter those by deaths or recovered or are still infected, or even you can find the number of new cases per day. So this is a very good example for this. One basic example that you may have encountered would be number of it would be like most classical categorical distribution, which would be differentiated on basis of students marks, like poor, below average, average, good, or excellent. And there's even another example. Suppose from home you are going to school. So let us just assume that there are no that's not a straight way. So what you can say is that your 2 categorical variables would be left and right. Now see, this is a nominal scale categorical variable. There's no order between them, and it's a categorical, and you can count. Suppose when you go to school, you need to take 3 lefts and 2 rights, and you reach your school. So this can be considered a categorical distribution. It's simple. So now we will study this in detail. Suppose there are 20 customers. This is pretty important one, so please understand it carefully. A rating is of ordinal scale from 1 to 5 rating. It's in order, so ordinal scale. So we will first construct a table. A table is given like this: 1, 2, 3, 4, 5, and a frequency is 2 of the customer gave 1 rating, 3 gave 2 rating, 6 of them gave 3-star rating, 5 of them gave 4-star, and 4 of them gave 5. So total of 20. So the thing is, what I wanted to tell you guys, let us just neglect this data for first. Let us suppose we didn't know the frequency here. So again, 1, 2, 3, 4, 5. Don't see this part, or let me just remove it for a second. Yeah. So good. Now the thing is, see, suppose the frequency of this was supposed to be xi, not xi, x1, x2, x3, x4, x5, and total number of customers was supposed to be n. So what we can say is that n equals to x1 plus x2 plus x3 plus x4 plus x5. I hope you agree. So here we can say that none of the frequency would be less than 0, It can be 0 but not less than 0, or you can say it cannot be negative. So to denote it in a correct way, we will write it like this: xi, I belonging to 1, 2, 3, 4, 5, or you can just say 1 to 5. So this would be greater than or equal to 0. Greater than or equal to 0. I hope you agree. And we all know that x1, x2, x3 and x4 and x5, these all are greater than 0. So this implements that n will be always greater than the sum of frequency. N will be greater than sum of frequencies. Let us suppose xi plus xi1, no, for example x1 plus x2 plus x3. I hope you understand, it's a simple concept. So sum of frequency taken one at a time, we cannot take two x1s, so it would be any frequency. So this will be less than or equal to I am just making myself confused. N will be greater than the sum of the frequency taken one at a time. Simple. So greater than or equal to sum of frequencies. So we can implement this, and from this, if n is a denominator in relative frequency, relative frequency, and in our numerator we either get sum of frequencies or individual frequency. It can be x1 or x2, like we found in these parts. So here see, n was 100, here f was 34, so 34 by 100 refers to the relative frequency of married. And if we need to find frequency of not divorced, so what we will do is to add up 58 plus 34, which will result in 92. So (58) plus 34 upon 100. So see, here I added two frequencies to find a single event. So see, I hope you can relate to what I was saying before. So this will be 92 by 100. So here what you will observe, this will be equal to 0.92. So here what you will observe is that this will always be greater than 0, greater than or equal to 0, and greater than, less than or equal to 1. So xi, I belonging to 1, 2, 3, 4, 5. So this will be less than 1, 0. You can say that. So every frequency will always be between 0 to 1. In summary, if you need to write it down, you may pause the video and write it. All the frequency are between 0 and 1. If it in a table it is not true, you may say that it's a misleading table, or it may not be a categorical variable, for instance. So here, this is about frequency distribution. Now, how to display these tables is one of the most prominent question asked. So the thing is, to display these tables we use two types of graphs. Either it's pie chart, or we can use what was it called, bar graphs, or you can say chart even. Yeah. So first of all, let us discuss pie charts. So in pie chart, first of all, what we need to see is this pie chart is a representation in form of circle. Okay, here radius doesn't really matter. What really matter is the proportion given to each variable. So it's one of the pie charts representation. So here, suppose there are four types of variables. This represents variable A, this represents B, C and D. So if these were grades, so you can say that most of the class scored less marks. How did I concluded that? I concluded this by saying that D has maximum proportion. Here's the thing. So advantages of pie chart is it's a good way to show that one category dominates over other, or you can say that it can also show if a category, this category has more than half, less than half. Okay, let's just write half or quarter proportion. You can just say by observing the pie chart. So all in all, it's all about proportions. Okay, I hope you understood. Pie charts is used whenever we talk about proportions. Simple. Now on other hand, when we talk about bar charts, in categorical variable we usually associate bar charts with Pareto charts. Now charts, spelling of Pareto, P-R-E-T-O, charts. Okay, so here order of bar chart is in terms of frequency whenever we write it along the axis. So the thing is, this type of bar charts usually have either increasing or decreasing. This is only one type of trend. So suppose by definition I would say that yeah, we can say it like this. This is used, Pareto chart is used for ordinal scale in what is it? Categorical variable. If you ask why, try to understand, pause the video and understand. So yeah, now the thing is, it is used because ordinal scale represents order. Ordinal scale represents order. Let me just use another color here. Sorry for writing in white only. So and Pareto charts can be used to show this order. Now, do you guys agree to my statement? Anyone who agree may think about it clearly. Was I right or wrong? Think about it. Think for a minute. So, the answer is this statement is incorrect. The thing is, ordinal scale doesn't mean that the frequency of the value of the category is actually higher. It can be low sorry, it can be lower or it can be fluctuating. So let us take an old example of ours. It was about, let me just copy it here, sorry, paste it here. So yeah, we had this example. Let us try to formulate a Pareto chart here. So 1 2 3 4, sorry, it would be the maximum one. I will be it can be either in decreasing order or in increasing order, it's up to us. But yeah, whenever you are asked a question on Pareto charts, if both of the options are given, increasing and decreasing, both are right, remember it. So here I'll be using increasing order, or let's just go with decreasing order so that there's no confusion. So 3 is the highest value. We will not look in this column. We will not look in this column, we will look in this one. Whatever will be the highest frequency here in this set, we will use it. So 3 is the first one with the highest of 6. So here 1 2 3 4 5 and 6. So 3 extends up to 6. For 4 it extends up to 5. For 5 it extends up to 4. For 2 it goes to 3, and for 1 it goes to 2. So see, this order is not actually the order defined by the ordinal scale. According to the ordinal scale, it should be 5 with the highest, as we discussed above. According to my statement here, 5 must have highest one, but it isn't true. We cannot restrict our frequencies, so now we can control them. So here Pareto charts represents highest frequency in the order. It can be either increasing, either in decreasing. One of the things to note is that to confuse some children, the questions are sometimes on the y-axis. So you need to take care of this. Like you, this can be shifted here. This can be shifted here. like y-axis interchanges to x-axis, and sometimes it's confusing, I agree, but you need to take care of these things. Okay, so this is about Pareto charts. Now I must also write the actual one, misleading one. So the misleading graph for this would be something like this for 1, 2, 3, 4, 5. Misleading would be like this. 1, 2, 3, 4, 5 and 6. So 1, 2 goes to 3, 3 goes to 6, 4 goes to 5, goes to 4. So it would be something like this. Now you can see the trend first goes upward and goes downward. So this doesn't define the Pareto chart. Pareto charts only goes in one trend. Yeah, two values may be constant at some point, but it doesn't decreasing. Okay, so just by seeing the graph you can say it's Pareto or not. Like in this graph one would definitely say it's not a Pareto chart. Now another concept is labeling. Now labeling. So see, if a data set has too many categories, the important information which is included in the graphs might get lost or concealed somewhere. It's not somewhere, it's just we wouldn't be able to observe it clearly or in efficient way. So what we can do is to group the categories. Okay, to avoid these situations. So this can be done by area principle. Now area principle says that it has its own statement that area occupied by part of graph should correspond to amount of area the data represents. Not amount of area, the amount the data represents. So it would be amount the data represents. So this is basically definition. What you can see is that suppose we had a super high graph data with something like this. Let me just show you an example. Wait a second.